What happens to the side length? Halve. Goes from 1, then there's 2, and then there's 4, so it halves, it halves, it halves. So this right here is going to be, the side length is 1 times what? A half times, so we know that this is equal to what? Equals to 1/4. That's correct. So we've gone from 1 to 1/4. If this had a side length, you can use ratios here. Could we just use the Pythagorean theorem if we wanted to? Let's use it. We can do that. That's fine. If we use the Pythagorean theorem, we know that this is going to be, that's 1/8 because it's half of the base. We don't know what this h is. So h squared plus 1/8 squared is equal to 1/4 squared. Should we use decimals at this point? No, 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 no. So h squared is equal to 1/16 minus 1. How many 64ths are there in 1/16? 4 of them. So h squared is going to be 3 over what? 64, right? So what is h going to be? Which is root 3 over what? 8. Okay, I'm good with that. So if you want the area of that triangle, what's it going to be? 1/2. What's the base of the triangle? 1/4 times the height, which is root 3 over 8. So we end up with root 3 over what? 64. So that right there, the area of the base is going to be root 3 over 64. So let's circle what we know here. We know there are 16 pyramids. The height of each pyramid is this, and the base of this base area is that. So if we want to do this here, A3 is therefore going to equal 16 times, what's the formula for the volume of a triangular-based regular pyramid? 1/3 the area of the base, which is root 3 over 64. The height, which is what? Root 3. Oh, what? The height is right here. It's root 6 over what? No, no, no. Different height. No, 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 no. The height of each of the pyramids is what? Root 6 over what? This is root 6 over what? That's the height of each pyramid, right? So it's root 6 over 12. Does this simplify a little bit? What do we think? It kind of does. You get 16 root 3 root 6 over what? 3 times 64 times. What's root 3 times root 6? Over 3 times 64. Oh, well, 64 times 12. You can cancel. What is root 18? That's 16 times 3 root 2. Because what's 18? 18 is 9 times 2. So you can fact. What's the square root of 9? 3. So you have this over 3 times 64 times 12. Can we cancel some things here? Yeah, we can cancel the 3's cancel, right? Cancel that, and this becomes a 4. So you end up with root 2 over 48. We end up with root 2 over 48.
The last one was 1 over 48.
That's true. We had this 48 here. Okay, so the number of pyramids. Good. Number of pyramids. Great. And then the area of a pyramid was 1/3 the area of the base times the what? Height. Do we actually have the height? Yeah, we do have the height. That actually is what? We just wrote it, didn't we? 1/2 to the times root 6 over. Absolutely. So this right here, let's just notarize this. This right here is the height of one small pyramid. Are we pretty close here? Yeah, what's the only thing left that we need to figure out? The area of the base just in terms of what? Just in terms of n. Just in terms of n. So let's actually look at that base there. Our base each time was a regular triangle, right? What were the side lengths of our original? It was 1, right? And every time you did a division, what happened to the length of the side? Halve, right? So that was A1. A2 was 1 times a half, right? Every time you do it, what happens? Times a half, right? So if this is the general one here, if this is AN, can someone tell me what the side length is? 1 times what?
N minus 1.
1/2 to the what?
N minus 1.
And do we have to write that 1 out front?
No.
No, goes away. So we have this. So do you agree that that's the side length of the base of the triangle? Okay, but is that what we need? We need the what of that triangle? We need the area. I agree with that. If we do this, remember how we've done this many times. We drop the altitude. What's the length from here to here? This is really tricky, everybody. What is it? No, in terms of 1/2 of that, right? Remember, when this was 1, this was 1/2, right? So it's 1/2 of that. What do you multiply by to get 1/2 of something? So you multiply 1/2 times 1/2 to the... So you have the same, right? 1/2 is the same base. What's the power of 1/2 right there? What do you do when you have this? We did this earlier in the course. What do you do when you have the same bases? What do you do with the powers? What do you do? So what do you get? 1/2 to the n minus 1 plus 1, which is what?
1/2 to the N.
1/2 to the n. Are you okay with that? Okay, we're getting there, everybody. We have 1/2 to the n. What are we really looking for? We're looking for that height, correct? Because we need to find the area of that triangle. Are we okay so far? What theorem are we going to use right now, Tony?
Pythagorean.
Pythagorean. So we have h squared plus what squared?
1/2 times 1/2.
Well, to the n
Or I was gonna.
squared. Yeah, you're right. 1/2 to the n times 1/2 to, yep, equals what?
Oh, I thought it'd be
Base, that squared, plus that squared equals the hypotenuse squared. So what's the hypotenuse?
it would be just yeah, 1/2 N minus
1/2
1.
to the n minus 1. What power?
2.
To the 2. So we need to simplify this. We need to simplify this very carefully. What do you do with powers of powers? What do you do with powers of powers? You multiply them. So this turns into h squared plus 1/2 to the what power? To the 2n equals 1/2 to the what power?
2N minus 2.
That's correct. What are we trying to isolate at this point? Nope. We're not trying to isolate n. You guys don't know how to isolate n yet.
H.
H. You're not isolating powers. No, we haven't done logarithms. So we have h squared is equal to 1/2 2n minus 2 minus 1/2 to the what power? To the 2n. Okay, let's pause for a second here because we have to be very